Hello everyone, welcome to the video. Today we are trying to solve the problem reverse array in groups. In this problem, we are given an array of positive integers and we have to reverse that array in a group of some size. For example, in this array, we are given that size k is equal to 3. So we have to reverse this array in groups of 3. So 1, 2, 3 becomes 3, 2, 1 and then 4, 5 becomes 5, 4. We are trying to solve this problem. We won't directly jump to the solution, but step by step, we'll try to see how to think and reach the solution. We discuss the questions of data structures and algorithms on this channel in simplest words with fundamental approach. If you are new to this channel, please subscribe. To begin with, let us first note down the key things given in the question. We are given an array of positive integers whose size is n, and the group size in which we have to reverse is given as k. For example, in this array 1, 2, 3, 4, 5, k is given as 3. So we have to reverse in groups of 3. So our output becomes 3, 2, 1 and then 5, 4. So if we consider our solution as a black box, basically as input we are getting an array, its size and k. And we have to return nothing because we have to modify the array in place. So what will our function signature look like? Our method name reverse in groups takes input as array, its size and k, and returns nothing. Now a few important things, edge cases that we can clarify with the interviewer here are that what do we do of the last subgroup whose size remains lesser than k. For example, here 4, 5, this size is 2 which is lesser than k. Should we reverse it or should we not? So this is one edge case. Another edge case would be what if k itself is greater than n? Like this is an array of 5 elements. What if k was given as 10 or 12? Then do we have to reverse the whole array or not? For our case, we will go ahead with reversing the array if k is greater than n. Before jumping to the solution, let us first try to visualize how is this reversing happening. So for example, here k is equal to 3. So we first select a block of size 3 from starting position. For example, in our example, this becomes the block. We reverse it. We know how to reverse it. 3, 2, 1, right? When this block is done, we have to select the next block. So the next block starts from here. It would have gone up till size of 3, but array itself is ending here. So the next block remains this. Then we reverse this and it becomes 5 and 4, right? What if the array was a bit longer and after 5 we would have 6 and 7 as well? Then we would have reversed this first and it would have become 6, 5, 4 and then this 7 would have remained as is. So let's first try to note down what are we doing. We are selecting a block. And how do we define a block? We define a block by a left index and a right index. For example, for this block, 0 and 2. Then 3 and 4. Okay, so how do we find the left index? Left indices in our example are 0 and then 3. This is for first block, this is for second block. So we simply start with 0 and jump in size of k to find the left index. Now how do we find the right index? Right index just seems to be here 2 and 4. So this is basically your left index plus k minus 1, and so that 0, 1 and 2 form one block, while this is not L plus k minus 1. This is actually end of array. So what is the logic of finding right index? The logic of finding right index is basically minimum of either of these two. Either it completes the full block, in that case right index will be this, or it does not complete the full block and we reach end of array, in that case right index will be this. Now once we know how to select a block, our next problem becomes how to reverse that block. Here is a generic array with some L and with some R. And let's say we have to reverse the elements between these. So what can we conclude? In the reversed array, this will be swapped with this. Similarly, this element will be swapped with this element and so on, right? That is how we'll reverse the array. Let us now try to put our thoughts into a concrete algorithm. So we know for sure that we have to iterate. And what do we plan to do in every iteration? In every iteration, we will select a block. And how are we selecting a block? By defining L and R. So in every iteration, we will have an L and we will find an R corresponding to that L. It will either be a full block or it will be a smaller block which is only till the end of the array. Then we call the reverse block function that will reverse the elements from L to R. Now how will the algorithm for this look like? Reverse block. In this also we have to iterate, right? And in every iteration we have an I and we have a j. We will swap these elements ARRI and ARRJ and move the pointers accordingly. And this will be a while loop till I remains less than j. Now, let us see a working code for the same algorithm that we discussed. Here is the function that takes an array list as an input, its size n and the size k in which we have to reverse. We first run a loop in which we jump I from I to I plus k in every iteration. We select an L which will be equal to I. Then we calculate an R which will be minimum of these two numbers. And then we have the block. So now we call the function to reverse the block. And in the reverse function, we simply maintain two pointers I and j with I traverses from left to right and j from right to left. And while I is less than j, we keep swapping the two elements and incrementing the pointers. You can find the link to this code in the description as well. To summarize, we first understood the problem with the help of an example. We tried to visualize the problem and we saw that how are we doing it? We are first selecting a block and then we are reversing that block one by one. We saw and wrote an algorithm for this, and the time complexity of this algorithm is big O of n, as we are seeing every element only once. And we also saw the code walkthrough for this problem. This is it for this video. If you have any doubts, etc., please comment below the video, and we'll meet again in the next video with some other problem. Thanks for watching.